For each problem, use implicit differentiation to find dy dx in terms of x and y. All right, so let me spread this out a little bit. Let me give myself a little bit more space. Wow, this is not going to be pleasant at all. 4x squared y cubed plus 1 squared. All right, here we go. Buckle in. Implicit differentiation involves me taking the derivative with respect to x of both sides. Like that. Left side, easy peasy, you get 2x. Right side, not at all. Right side is chain rule. And if you remember, chain rule has some type of outside stuff, in this case, squared. And then you have some type of inside stuff, in this case, 4x squared y cubed plus 1. In order to do chain rule, you take the derivative of the outside stuff, keep the inside stuff the way it is for now, and then take the derivative of the inside stuff. That's where it's going to be a killer. Okay? So, the derivative of the outside stuff has me bringing down 2 and turning that 2 into 1, no big deal. Keep the inside stuff the way it is. So 4x squared y cubed plus 1. Now we are going to multiply everything by the derivative of the inside stuff. So I'm going to create my own section over here to do the derivative of the inside stuff because it's not going to be pretty. All right, so this is going to be the derivative of the inside stuff. The inside stuff was 4x squared y cubed plus 1. Taking the ddx of that, taking the derivative with respect to x of that guy right there, has me looking at you and saying, ugh, that's product rule. U would be my u, u would be my v, so I need to do u prime v plus v prime u. All right? So, the derivative of u with respect to x is going to be the derivative of 4x squared. Easy, 8x, no big deal. Multiply everything by v as is. So that would be y cubed, no big deal. The derivative of v is going to be the derivative of y cubed with respect to x. That's going to be 3y squared, but since we're taking the derivative of a y, you attach dy dx to it. Multiply that to u as is, so 4x squared. Okay? And then what we haven't done yet is the derivative of 1, which is nothing. So let's clean this up. So we've got 8xy cubed. 3 times 4 is 12. X squared, y squared, dy dx. So that's the derivative of the inside. So we're going to multiply everything to the derivative of the inside, which was 8x y cubed plus 12 x squared y squared dy dx. I guess what we can do is, since I have this whole guy divided or multiplied to that whole guy, and my job is to get dy dx all by itself, let's completely eliminate the blue guy. So let's divide everything by 2, 4x squared y cubed plus 1, 2, 4x squared y cubed plus 1. Okay, all of that goes away, and fortunately the 2's go away. So on the left, we have x over 4x squared y cubed plus 1. That's going to equal just what's here in black, so 8xy to the third plus 12 x squared y squared dy dx. Let's subtract this guy from both sides. So I'm running out of space here, so I'm going to do this. I'm just going to subtract, make it look like that. Okay. Sorry for the silence, there's just not much to say. And now, oh man, now I'm going to divide everything. Oh, this is a nightmare. Divide everything by u. Ugh. So maybe the best way to multiply that out and the best way to make that look instead of dividing it is by multiplying both sides by its reciprocal. I just think that'll look a little bit more pleasant. It's still going to be awful. It's still going to be so bad. But if I multiply both sides by 1 over 12x squared y squared, 1 over 12x squared y squared, I can maybe do some stuff, but I don't know. I don't want to do anything with this. I just want to leave it like that. So what an abomination of a problem. dy dx is going to equal 1 over, I don't need that parentheses, not yet. I'll scoot you over. 1 over 12x squared y squared times the quantity x over 4x squared y cubed plus 1. So you'd have to distribute there if you wanted to, minus 8xy cubed. So that is the answer. It's awful. It's terrible. I mean, look at the original problem. It's going to be awful. It's going to be terrible, but we did it, and that is a possible looking solution. You could go further. But I won't because I don't have space. And these are my videos. I do what I want. But yeah, that's implicit differentiation that involved both chain rule and product rule. Puke. Thanks for watching though. Like and subscribe.